In the last lesson, you learned how to automate desktop applications and acquire useful data. Now you'll learn how to save and manage it. We ended up getting a text value from the application and displaying it in the message box using the result variable. You can tell that this is a variable by its name, beginning with a $sign. If you're not familiar with the concept of variables, you can think of them as named memory storages which can contain information. Numbers, text, images, tables, and more complex objects, lists, dictionaries, collections. All of these are data types. When we use the name of a variable, we imply that the program should replace it with the data stored in the variable. But depending on data type, it will be interpreted differently. To work this out, let's start over and recreate the result of the algorithm from the last lesson. In the properties of the start block, you can specify the names of the variables and the values they will take when the diagram is started. This way of declaring variables is implicit. However, you can declare a variable explicitly through the Variables panel in the lower right corner. It provides you with advantages. You can see all variables. You can set the type and the initial value, even for variables of complex type, list, table, etc. Also, when debugging, this panel displays the current values of the variables. Let's name the variable stock and specify its value from the last lesson, 14. There is one tricky thing. The block that saved it writes the result of its work as text, regardless of the actual content. So we write 14 in quotes. Let's move the message box block and specify the variable stock as the message. Let's make it more informative by adding quantity at the beginning. The text must be specified in quotes, as you already know. To set both text and a variable as a properties value, you have to combine them in an expression with a plus sign. Sherpa Designer uses an expression language similar to PowerShell, which has this logic. All the operands of an expression are converted to the type of the leading operand. Let's move to the console, which you can find here. Here you can enter an expression and get its result. The regular mathematical addition of numbers results a number. If the expression starts with a text, the next number is interpreted as a text. And the plus operator becomes a concatenation, a merge of texts. But what if you need to merge text with the result of a mathematical operation? You just need to put it in brackets, making it a sub-expression. Trouble starts if the first number is stored in a text-type variable. This can be solved by putting the number at the beginning of the expression. Then the text will be implicitly converted to a number. Some examples of implicit conversions. Text plus number equals text. Number plus text equals number. Text multiplied by number equals text. Text characters repeated 3 times. Number multiplied by text equals number. Minus and divide operators always convert operands to a number, regardless of their order. Let's assume that we need to print 1/3 of the value obtained. Add a division by 3 to the variable and put it in brackets. First, it is no longer convenient to work. The width of the field is barely enough to see the entire expression. If you click the button with 3 dots, you open the Edit Expression window, where the input field is much larger and more comfortable for working with long expressions. But that's not all the convenience. The entire bottom part of the window is an interactive guide to everything you need to build an expression. Here you have a list of all the variables that are specified in a diagram or project. In the tabs of the guide, there are many examples, such as how to specify numbers, text, escape special characters. It's not always obvious at glance what kind of example is in front of us, but each of them has a comprehensive description. Now the result looks cumbersome for our human perception. I want to run the number down. The hint for the solution can be found in the guide in the Math Functions tab. The floor function will fit just fine. If you double-click on the example, it will be copied to the current cursor position in the expression. All that's left is to move the division in place of the number in the example. And test it. Now the expression results the required value.